The question considered here is a very popular type of problem and generally comes in the form of a 1 mark problem in GATE, and this is on Zener diodes. So herein the problem is stated as that if you consider the Zener diode to be an ideal one and the Zener voltage is 6 volt, then can you find out the output voltage V0 in volts? So this is a pretty typical Zener diode circuit, and we can see that here it is capable of providing the load regulation provided the Zener breakdown hits 6 volts. So the way to solve for this type of question is it's a two-step process. In the first step, what you have to do is to eliminate this Zener diode from the circuit and then try and find out the voltage drop across this open circuited Zener diode. And this will give rise to two conditions. The first condition is that if this open circuit voltage, if we name it as VOC, so if this open circuit voltage VOC exceeds the Zener breakdown voltage Vz, or even if it equates to Vz, then the Zener has reached its breakdown mode, its reverse breakdown mode. And under that circumstance, the output voltage will be the same as the Zener breakdown voltage. So if you bring back the Zener diode into the circuit, it will move into the Zener breakdown mode, and therefore V0 will be equal to Vz, and you get regulation. Whereas the other case could be that the open circuited voltage is less than that of the Zener breakdown voltage, and this implies that the Zener diode has not moved into its breakdown mode. So if it has not hit the reverse breakdown region, then the Zener diode will remain open circuited, and therefore whatever the output voltage that you found for this typical voltage divider circuit will be the same as the output voltage of this network. So it's as if the Zener diode was not even present in the circuit. Note that this is when we are considering the Zener diode to be an ideal one. So if we use these two steps, it is possible to solve for basically any kind of Zener diode voltage regulation circuit. So let's return back to the question in hand, and what we do is in the first step we remove this Zener diode from the circuit and try to find out the open circuited voltage VOC, and we can find that this is a voltage divider circuit where both these resistances are same and you have an input voltage of 10 volts, and therefore the voltage drop across these two terminals will be equal to 1 by 2 multiplied by 10 volts, which is equal to 5 volts. Now note that this 5 volt is less than the Zener breakdown voltage that was mentioned in our question. So in the question they have mentioned the Zener breakdown voltage as 6 volts. Now because this open circuited voltage is 5 volts and this is less than the Zener breakdown voltage, therefore condition 2, this condition is applicable here, and we can write the output voltage V0 as the same as the open circuited voltage, which is equal to 5 volts.